All right, hello everybody. Welcome to our webinar today, CAD and CAM. We're going to take a couple minutes and we'll start a few minutes later than 12 o'clock. We'll probably start at 12:05 just to make sure that everybody that wants to be here has a chance to get here before we start. So sit back for a couple minutes and we'll get started here shortly. But welcome, glad to have you join us today. I'm Alex. I'm the Director of Marketing for the Americas over on the Western Hemisphere for SimSystem Americas. Got two great panelists with us today. I'll introduce them in a second. But glad you're here. Just, yeah, this is should be great. We've held this topic, this conversation a couple times in the past, and it's always um, just been very fruitful. We've had great discussions. We welcome you to just join that discussion today. At the end, we'll have Q&A. But for the most part, just we'll be talking through Exocad and MillBox integration tips, things to be thinking about, watching out for as you're designing your files, that you have to design with CAM in mind, with your tooling in mind, different pieces to make sure you have an optimal outcome. So these guys will walk through some of the more common issues that they've run into. And help you just make sure you're aware of it, or as you move into more advanced workflows that you know what to be looking out for. So, like I said, I'll give it 3 more minutes. I'll be quiet here for a second, and then we'll dive right in. So thanks for joining us. I'll actually start while I say I'll be quiet, but as I do, I actually have a poll for you. I'll go ahead and start that up, and we just got a couple questions for you if you wouldn't mind answering. I'll just start that, and you can certainly do that as you wait for us to begin. So I'll start that poll. Awesome. Thank you. Yep, people are getting in the poll. Good. Yeah. Just a few questions. Wondering who's here today. If we have mostly doctors or lab owners, techs, or if you're with a supplier. And if you're in a supplier, we're asking if you're in if you're in a commercial role, like you're a sales or somebody like that, or if you're in a tech support role. Just the results will help these guys kind of know who's here. For your info, we did some surveying on the front end when you registered and to see who uses Exocad, who uses MillBox, and honestly, it's a pretty good mix in the room of people who do use either or and don't use either or. So if this is your first intro to either Exocad or MillBox, I'm sure these guys are glad to be showing it to you if you're familiar with a different system. Hopefully, I'll speak for MillBox, Daniel can speak for Exocad, but hopefully you'll see MillBox, how easy it is to use, just how smooth the interface looks. Don't let the simplicity fool you. There's so much behind the scenes, so much access and capability within MillBox that it truly, I think, outpaces any other CAM software. At least, I mean, definitely, we're developing at the cutting edge of the CAM softwares that are available, far beyond maybe the OEM versions that are also trying to sell machines. We're only developing the software, so really our software is extremely advanced and high quality concerning the strategies. And so if this is your first introduction to MillBox, again, don't let the simplicity and the high quality of the interface fool you and make you think it's simpler than it actually. It's very, very robust and it's a solid CAM software. So and Exocad. Geez, I can't speak too much to it, not being a user myself, but obviously it's incredibly popular and well used in the market. And I'm sure you're familiar with the brand, even if you haven't used the product. So,
And if you're using anything else, you should repent and come to the light side and
yeah,
use
for
the
sure.
superior option. Just kidding, just kidding. But seriously,
Well, yeah, for sure. Yeah, we got that's awesome. That's Daniel's perspective here. That's good. And yeah, asking what you mill. Great. Looks like a lot of people are doing crown and bridge. So I'll just start reading off the poll since we've got almost all of you participating that are here. Looks like we mostly have lab technicians and people that are in tech support roles in labs. We do have a few doctors and lab owners here, but primarily lab techs and tech support. So welcome. Glad you're the people that we normally are training, and it's fun to have you. And you're the front lines, and so we really are glad you're here. And obviously, that makes sense that you're here because this is very relevant to your life, even more so than somebody in a commercial role. So, and then, yeah, a lot of crown and bridge, hybrid abutment, all on X. It's a good mix. Not a lot of bars and dentures comparatively. So, yeah, awesome, cool. And I asked a question about because Daniel is an Exocad superhero in the presence of yeah Superman himself here, and yeah, it looks like most of you are gonna bypass any kind of flight, invisibility, super strength, but you would all like the mostly like the ability to achieve a proper fit on your parts and not have any remakes. So it's a logical. I understand why you might want that superpower. There might be others that we hope for, but thank you for. Hopefully that helps the guys know a little bit about who's here since we can't talk to you really. Since we can't talk to you, just want to mention, please feel free at the end. We're going to have a Q&A at the end of this session. And the only way for us to take your cues is for you to drop them in the chat. I'll be your moderator for this time. Again, my name is Alex. I'm the Director of Marketing for SimSystem Americas. I'm happy to welcome Daniel, Portal, and Yago to our session. I'm going to start sharing my screen quick, and I'll take the first 5 minutes. And like I said, 12:06, 1 minute late. Let's begin. So let me share my screen. All right, so we are SimSystem, so welcome. Like I said, I'm Alex. SimSystem is a dental software company based out of Milan, Italy. I'll actually skip ahead a couple slides and we'll come back here. But let me tell you about who we are as SimSystem. SimSystem is a leading CAD/CAM software in both dental and industrial manufacturing. Here, actually, let me get rid of, I think you might be able to see this. And we were founded in Milan, Italy. So the company is headquartered there in Milan. You can see the beautiful Cathedral of Milan if you get to visit. And started out in industrial and developed dental software. I forget when, many, many moons ago. And so we've got a lot of customers now all around the world. One thing that separates SimSystem as a company compared to other developers in the dental space, especially in CAM software, is that we're an in-house software development company, which means that we implement and actually develop the software itself, which means you have quicker access to development requests and customizations because we're in-house, not outsourcing that to another, which again, I'm saying is unique to SimSystem. So great support in that way. We've got great solutions, and we're updating all the time. There's a really frequent pace of updates and implementation. So yeah, that's us a little bit. We've got three primary dental softwares, MillBox, Make and Mill, and Paramus. My computer's not working for some reason. And they are, yeah, MillBox is our flagship dental cam software you're probably familiar with. Make and Mill is a hybrid software that will take 3D printed parts printed in metal, SLM metal printing, and then refinish sensitive areas like the internal of a cavity or in non-USA workflows, it could be an interface. That's a really, they overbuild the part and then you just refinish the sensitive areas. And that's being used more and more. It's already used a lot around the world, being used more and more in this hemisphere, Western hemisphere. And also Paramus, the 3D slicing software. So I'm going to exit this. PowerPoint stopped. And let me tell you about these guys. So today with me, I've got Daniel Portal and Yago Leal. Hey guys, good to
If
see
you
you.
want, I can share my the PowerPoint here.
Mind, we can see your faces in another view. Thanks, Yago. Um, yeah, so very thankful to have these guys with us today. We've got two really smart minds in the room here. We have Daniel. So Daniel is the founder and director of Portal Digital Dentistry. It's a company that's trained hundreds of dental professionals around the world. Reading from his bio, it says, as former senior trainer for Exocad North America, he was responsible for educating Exocad resellers, labs, and dentists around the world. In this role, he traveled extensively to teach lectures and demonstrations at trade shows in Germany, Canada, Argentina, Colombia, Brazil, Spain, Mexico, and many other countries. So Daniel, definitely, he's spoken for us before. He's been all over the place. He's probably helped a lot of you, helping with outsourced design, whether from the beach or his house. He's helping you out. So Daniel's a he's an Exocad superhero if you haven't seen the latest marketing. So definitely somebody worth talking to if you need to design cases, I can let him tell you about his business here, maybe at the end or wherever. Let him prove his worth here. But but yeah, that's Daniel. Yago is our chief technical guy here in the Americas. Yago oversees. Yeah, hey Yago. Yago is I'll read from his bio as well. It says Yago has a bachelor's in manufacturing engineering with 13 plus years of experience working with dental CAD CAM systems. He's the founder and owner of Blue Digital Lab in Curitiba, Brazil. And Yago moved from Curitiba, Brazil. He's been working with us for several years, helping with the IMIS and the roll-in installers, definitely, and then everything else too. But historically, those have been his main responsibilities. And he's he moved to the States and he moved away from us in Louisville to North Carolina. And Yago's truly one of the top experts in CAM out there right now, especially concerning MillBox and our strategies. So thank you guys very much. Yeah, we covered these slides. Thanks for showing them, Yago. I'll just speak. Yeah, we have many global offices. If you need to get support in your own region, that's an advantage of our company. And you can see these stats, a lot of, just a lot of community built up around SimSystem and MillBox that you get access to as a user. So let's turn to the experts, Daniel and Yago. Thank you guys so much for being here. I'm really thankful that we get to tackle this topic, just connecting the dots between design and machining, just talking about CAD and CAM. I'll let you guys take it away, Yago, if you'd like to just start it out. Take it away.
All right, thank you, Alex.
Mhm.
So in today's seminar, we are going to discuss a little bit what you do at the CAD that will have an impact on the CAM side, so on the machining side. So small things that you should consider when you are designing your parts. And some of those things that we are going to discuss here are things that usually the users, like the designers, they don't realize when they are designing, but it's very important for you to consider when you're doing the design, because it's better for you to try to anticipate like an issue at the meeting at the design point. So if you have knowledge about what we're going to discuss here, it will help you a lot in future case that you are designing. So the first topic that we are going to be discussing here is regarding the material selection. And this is very common for any designer, I would say, to select only one material for all of the restorations that they are designing. I've seen a bunch of people like just selecting zirconia for everything, but that will cause you an issue, and mainly a fitting issue when you are meeting your parts. Because I don't know if you ever realize, but at least in Exocad, in 3Shape is the same. But in Exocad, you can see that when you are selecting the material, you can see all the like parameters regarding like cement gap, margin thicknesses, and everything during that area here. And if you change from one material to the other, you see that those values sometimes they will change. So you can have like different cement gap parameter, different margin thicknesses parameter, and that will impact when you're milling a case, because a zirconia is milled in a different way than we mill like titanium, for example. So if you select zirconia for everything, but you're milling your part in titanium or glass ceramic or any other material, it will have an impact on your case. So it's very important for you to select the proper material at the CAD side. Daniel, I don't know if you want to say something else regarding these or show in Exocad where you can.
Yeah, I can share here my screen real quick so that everybody can see what you're talking about. So whenever you select the different materials, you will see all these values, or at least some of these values change depending on the material that you're selecting. So just as a quick minimum thickness, for example, if you select titanium, says 0.5, but if you select zirconia, then it jumps to 0.6. So those are some of the changes that you will see from one material to the other. And then we can get into these also, but some of those will also be changing depending on the material that you're selecting.
And I believe you can configure that according to your needs as well, right? So you can save those parameters.
Yeah. So what Exocad allows you to do is to create doctor-specific parameters. So as you fill out an order form and you fill out the information here for your client, for your doctor, you can actually set default values for him. So let's say Dr. A, whenever you mill zirconia, he likes, I don't know, a distance to antagonist of 0.5 millimeter. You can change that here. And the moment you click OK, that parameter is saved as a new default every time you select this doctor and every time you select this restoration type in that same material. Now that will be his new default value. And so now you don't have to have all these little post-its all around your screen as I used to have when I started designing to try to remember every doctor's specific parameters. You can just input it once and then it's done for you.
It's awesome. All right, so let me share my screen back. And let's go to the second point. So this is a very simple point, but a lot of people select like only one material when they're designing, and that's not ideal, like we just discussed. The next point here, it is regarding the tool compensation. And this might have a different name on TreeShape, but on Exocad it's called tool compensation, and then it will show you later. But as you can see here on the image, so this is the same prep, okay? It is like a central teeth here. And what this feature is doing, it is allowing the internal prep of the crown that you are designing some space for a tool to get inside, okay? And this will result, like, this will depend a lot on the settings that you have on the CAM, on your milling software and your machine as well. Because, for example, on the top view that you can see, there is no compensation regarding the tool there. So that part, like close to the tip of the tooth, it will be very narrow. So you need to have like a smaller tool to get inside to be able to finish properly those areas. Usually on the CAM strategies, we set the 0.6 only on the anatomy and not internally on the crown, because usually those default settings on the CAD side, they will compensate for a 1mm tool to get inside as default, but you can change it. It depends a lot on your configuration, on what the dealer configured for you. But usually on Exocad, I believe it's like 1.2, if not mistaken, or 1.1. So it will compensate for a 1mm tool. So this means that if the 1mm tool is not able to get inside of this area here, it will compensate and create those bigger areas there, allowing the 1mm to get inside. And some people, they reduce that value to 0.7, 0.6. If you're doing that, you need to make sure that your CAM is properly set up to use the 0.6 inside. Otherwise, you end up with rest material, like some material that the machine will not remove. So an example, this one here. So here in this case, I have the same crowns that I was showing you. One has the compensation and the other one does not have. As default on this version of my CAM, I'm not using the 0.6 internally, only for the anatomy. So this means that the 0.6 is not getting inside of the prep here. And you will leave up with material on one of the crowns because the 1mm is not able to cover it. So that's one situation that when you're milling something, you can fix that on the CAD. If you don't know how to fix that on the CAM, you can do that as well on the CAM side, but you can also fix that on the CAD. So if you want to stop sharing mine.
If I may, Yago, if you want to put that picture back up. So
yeah, sure.
The main thing to understand from here is that if the mill does not get there and you have extra material, then your crown is not going to sit. It's going to be held up because it didn't mill enough on the interior for your prep to sit properly. Now, the thing to consider, and sorry, I don't have a visual for this, but if you're talking about a lower anterior crown, it's going to be extremely sharp. And if you don't set your parameters correctly and say you're telling the software that you're going to be using a 1.2mm burr, which is what Exocad defaults to, then the software is going to add around your prep all this extra space, and hopefully my visuals here with my hands work. It's going to add all this extra space for that 1.2mm burr to get in there and mill. Now, the problem is that will create a lower anterior crown that will look extremely bulbous. And so if you understand your mill and you know that your mill does use a 0.6mm burr, then you can actually change that value in the software, making sure that the CAM also understands that value. And now you can take your compensation tool from 1.2mm to say 0.7 or 0.8, and you just gain 0.5 millimeter of thickness. And that could be the difference between a bulbous looking crown and a more anatomically correct looking crown. And so it is extremely important to understand that value. Now, if I may share my screen here, I just want to get to the step where we talk about that here in my software. So when you are designing, this is again in Exocad, when you're designing your crown bottoms, if you go to the advanced tab, you get to see that anticipate milling value here. Okay, and now it wants to know the diameter of the tool, not the radius. So just be careful with that. And so right now it is assumed a 1.2 millimeter burr, even though we all know that the burr is actually 1 millimeter. Now we add a 0.2 just because there's oscillation during the milling process, and you just want to have a little extra space for the burr to be able to move in there. And so if you are using a 0.6 millimeter burr, then you can actually change that, move that back to 0.8 or 0.7. And that will give you enough room for you to be able to mill, but also gain all of this extra space that would have been lost to the necessity of the over milling. Now, again, because we're talking about milling, that's what we're going to focus on. If you're printing, you can actually just get rid of this value altogether. Yeah. It doesn't matter. Mm-hmm. But when it comes to milling, understanding your mill and understanding the capabilities of your CAM software play a huge role here. And Yago, sorry, if I can just take one more second.
Sure. Go
One
ahead.
thing to also consider, which a lot of people bypass really quickly, is by understanding the mill that you have, you actually get to select that up here at the top of the material options in Exocad. So if you have a chairside mill, which is typically 3 or 4 axis, make sure that you make that selection. First of all, it limits your materials, but it also, the way that it's going to treat undercuts and other problems, let's say, during the design process, will be different. So a 4-axis mill can only move the tool up and down. It does not tilt it one way or another. So it cannot mill undercuts. And so this will allow you to take that into consideration during your design process. So
it is very helpful when you're designing bridges.
Correct.
For a 4-axis mill.
Very much so. And so understanding this option here, which is, I don't know why it's kind of hidden, but make sure that you understand whether you're printing, your mill has 5-axis or 4-axis, and make that choice at the very beginning. That's all.
Let me share my screen here. Yeah, and you can see MillBox, right?
Yes.
Yeah.
Okay, great. So in this case here, like we were discussing, I will need to enable my 0.6 here to work on this area. And another limitation that I might have, this is the part that Daniel mentioned, like you need to understand the mill that you have and the tools that you have as well. Because there are some mills that the 0.6, it is not cylindrical, it is conical. So if you have a conical tool, even though the tip is 0.6, sometimes because of the tapered part of that tool, it will hit like in walls like this, and the tool is going to be able to mill those areas. So you need to understand the physical limitations that you have, because if you're printing, you don't have as much limitation as when you're milling. With milling, you have so many limitations, like you have tools, you have angles, you have the material itself. With printing, it's basically like going layer over layer. So you can do a bunch of things that you cannot do on the milling side. So on the milling side, you have way more limitation than printing. So just understand the tools that you have available for your machine, because even though if you have, let's say, a cylindrical tool, but the length of your tool is only 2 millimeter, sometimes the tool is not able to get inside that area as well. So the software, when you're calculating the tool paths to be able to mill this case, it will always try to prevent collision. So there's something that we call collision control in the software that is always activated. So if the tool is not able to get into that area to mill, to remove that material, it is not colliding or hitting your part. So you're safe in regards to that. So it will never cause a collision. But you need to take in consideration that you have a physical limitation here. So if you need to mill like this, you need to have a bigger tool or a different shape of tool to allow us access to that area as well. We go back here to the presentation. Do you want to add any other point regarding this?
Not for me, no.
Okay, great. All right, so the next point is regarding anatomy and interproximal details, because I've seen a lot of designs where you import the crown, let's say you spend, I don't know how many minutes designing your parts, making sure that the grooves are very deep and you have like a very, very nice crown. But then on your machine, let's say you don't have a 0.6 or even a 0.3 millimeter tool in this scenario. And this means that the time that you are spending on your design, it will not be reflected when you're milling that part, because you don't have tools that will be able to mill exactly the grooves and anatomy that you are designing here. So just make sure that on the CAD side, if you are designing something, you're designing something that the machine will be able to reproduce. Otherwise, you're just spending your time designing something that won't be reproduced.
If I may, Yago. So if you, so I am a firm believer that the library that you choose should put the level of detail that you want. Okay. So if you find yourself digging in your grooves and all of that, may I suggest that you're just using the wrong library. Okay. You want the software, I guess, or the tooth library to do that for you. But if you go and spend time doing all this, so for example, this level of detail here may be just fine, what we see here on the distal side of the crown. Okay. But when you get to the central fossa, you can see here the level of detail that I created. Now, to go off of what Yago is saying, if I was to take the time here to measure this, okay, I can go here and look at that groove. And now if I measure the width of that, I don't care what milling machine you have, you're not getting that level of detail. And so you just spent all this time digging in your anatomy and you're not going to get it. It's going to get washed out to the point where if you have the tool, maybe a 0.3 millimeter tool, so all of that detail you just created is going to get washed out up until about this point here. Okay, just to kind of round it up to 0.3. So all of this depth that you created in your design is gone. And so it's not going to come out. So understanding that part of it will also allow you to focus on details that are addressable, if you will, on the design side of things, or if you just need to invest your time elsewhere. Now, I am a proponent that if you like the overall, so just to show you what the library looked like at the very beginning, if this is not good enough, then you know that you are going to have to spend some time manually in the green state digging in your anatomy. It is much better for you to spend that time there where you can actually see the final product right away, rather than try to do it here and then get frustrated because you don't get out of the mill machine and still have to do it manually anyway. And so pick a library that gives you the level of anatomy or the shape of the anatomy that you like. And then you understand yourself that, okay, I'm going to have to spend another, I don't know, 10, 15 minutes digging in anatomy here after it comes out of the mill. But because we are able to zoom in on these crowns at, I don't know, times 1,000, we get to see some details that are not going to be visible if the crown was real size. So if I zoom out to the actual size of the crown, a lot of those details that we're focusing on are automatically gone. And that's kind of the way that we need to understand this part of the process, that certain details are not to be even considered during the design process because they're not going to be visible in the final product. And so our time is better spent creating those changes where we can actually see it and make sure that those changes are actually implemented. That's all I had for that.
Thank you. Yeah, and regarding that as well, like not only on the grooves and anatomy, like on the interproximal details, like between one tooth and the other is the same. I've seen a bunch of people like designing like a bridge or something, and sometimes they have like a really small gap between one tooth and the other. That, like, depending on how high that gap is, the machine will not be able to mill it, even though it's a 5-axis machine. And you are like, it can be that you cause a tool break depending how deep it is, if, by the way, the tool is able to get inside as well. So yeah, try to avoid those types of designs and understand the limitations of your machine for sure.
If I may, just to share kind of what you're talking about. So
Yeah.
I have a really ugly bridge here that I was designed just to show a couple of things that could go wrong with the design, but you're in proximal areas. So I get a lot of requests, like I want really deep in proximals. Okay, that's great. I can make this extremely deep, okay, and make it look lifelike. The problem is your mill is not going to get in there
Yeah.
because of the same concept. If I was to measure from here to here, so all of that detail that is below that line, more or less, is going to be gone because the mill cannot get in there. And so again, understanding those limitations will help you save time in the design part of things, and will allow you to allocate your time resource in the correct step at the right time to take the advantage the most per case.
And in this case, the way that you design here, it will probably cause a tool break because of the shape of your interproximal area there. You have like an oval shape, let's say. So probably the 0.3 millimeter will get inside that area or try to get inside that area, and it will cause a tool break because the way it is.
There you go.
So on the right side, it is correct because you have like it rounded, but on the left side, you create like a fossil or like a hole there. You see that you have those
This
2
right
points
here?
there. Yeah, no, looking from the top.
Okay.
Yeah, zoom in on the bottom part of the interproximal area.
Right here?
No, the bottom part. Yeah, there we go. This area
This right
here.
here.
Yeah. This will probably cause a tool break as well.
Right.
Yeah, the tool try to get, so something like this would be ideal. Because even though you get that detail in the design, the milling machine will not be able to reproduce it. The majority of the 0.3 millimeter, it's either conical or you have like a 2 millimeter length of tool. So a 2 millimeter length of tool will not be able to get inside down to that to have access to that area there.
Correct.
So
yeah, I just wanted to show another place where people tend to require or request a lot of detail from the design side of things that gets washed out the moment you manufacture this. And so you're very deep in proximals, you're very deep anatomy. Those are all, in my opinion, waste. It's a waste of time to try to create that. Now, there is a point where you can get there's a difference between that level of depth and something like this, right? So I understand that there's some level of detail that is required. But if I was manufacturing this, I would leave it like that. And I understand that I'm going to have to go over this with a disc to better define my inner proximals. And that's okay, because I'm going to have to do it anyway. Whether I do it here and it doesn't come out, or I just do it afterwards, I'm going to have to run with a disc over that inner proximal regardless.
If you're milling zirconia, it will be a little bit better because you're milling zirconia 20% bigger, then it will shrink after the sintering. But if it's PMA or composite or any other material, yeah, for sure.
Yeah.
All right, let me share again my screen. Okay. So the next point here, it is regarding libraries for tie bases, right? So this is a talk that it's more like a personal opinion of mine, but like we just discussed at the beginning, depending on the material that you select, the software is going to apply different milling parameters for you, like a cement gap or thicknesses or any other parameters that you have on the CAD. But when you are designing a case to be used with a tie base and you use a library, so like a library, like an implant library like this, but to be used with a tie base, you cannot control those parameters to be used on this tie base because the tie base, it will still be cemented on the part that you are milling, right? So the problem here is, for example, the same library you use the same library for zirconia, you use the same library for PMA, for composite, for glass ceramic, for titanium, for any other material. Those parameters like thicknesses, cement gap, it is dictated by the library. It's not dictated by the settings that you have there on the material, because that's not only Exocad, that's any other CAD on the industry. The library itself, the design of the library will be what will be dictating the cement gap. So if you design a part with a tie base and you design that in zirconia, it is exactly the same cement gap as if you are designing that in titanium. And that will for sure cause you fitting issues sometimes. So I don't know. That's to me, it's a CAD flaw. I think we should have control of expanding, let's say, the cement gap on tie bases. There are a few libraries that they give you the option,
Right.
like plus 20 microns or whatever,
Yep.
but just a few. I don't see many of those.
Correct. And so to go off of that, if I may,
Yeah.
what Yago is talking about. So let me pull this up. So if we look at the, where is it? Yeah, right there. So that is the part that we're working with, and the software creates that red area. That's my minimum thickness. Okay, and so the cement space will be the area between these two. That is set by the library by default. That happens whenever you use a library, okay, an implant library. Now, as Yago said, there are some libraries that do offer you some micron differences in the cement space. Very few, very, very few. And so a shift that's happened, at least in my personal business, is a lot of my clients like to scan the tie base in the mouth. Okay, and the way that this is done is you will scan the tie base in the mouth. Obviously, you're not going to get all the information, and then you take the tie base out, and then you scan it extraorally, and then I can marry the two images and come up with something that looks like this. Now, whenever I have this, then I'm able to treat that tie base as a prep. And for all, practically speaking, that's all it is. And so as I go through the design process, I have the same exact access to all of the tools for a regular crown design. So I can play around with my cement space. I can play around with the way that the margins are going to be looking, tool compensate, all of that. I get to play with it if I want to. Now, there's some benefits to doing that, mainly what I just shared, but also you don't have to have a huge stock of all kinds of different scan bodies that you may or may not use in the future. Tie base you're going to use either way. And so it adds benefits on that side of things. Now, to be thorough, I don't have, in my personal business, I don't have many problems with fits using the libraries. So it's not like it's a do or die, you have to switch. No. But some doctors are pickier than others in the way they like their things to fit. And so if a doctor really wants to fine tune the fitting of their restorations, then this is the only option, depending on the library once again. And so just know that if you want to use libraries, it'll work, no problem. If you want to use this, it'll also work. Exocad ends up being agnostic about the process you want to follow, but it supports you either way, so that you can either really fine tune the fit of your restorations, or you're okay with what the default gives you, which it's going to be okay the vast majority of the time. But just know that there are options out there in case that you run into problems.
Yeah, and even though the libraries offer you to be able to increase that gap there by having like different sizes of the internal prep, you still need to remember, oh, I'll have to use 30 microns for PMA or 40 microns for titanium, for example.
Right.
So you still need to have like a table or something. And remember, every time that you're doing PMA, you have to select that exactly value here when you're designing.
Yeah.
So in regards to that, we have a way that might be helpful for you to manage that in an easier way in MillBox. So when you are milling any type of crown or a tie base like this in MillBox, and if you need to adjust the cement gap, so the internal prep of the case that you are milling, if you want, you can increase or even reduce if it's loose a little bit. But of course, if it's loose, you have to remill again, right? Because we cannot add material here. But if it is tight, if it's still in the machine, you didn't remove that from the puck, you can still increase the adjust here for internal part of the tie base here, for example, and you can remove that again, just the cavity operation to make it a little bit looser on the internal. So on the software side, if you want to make your part, like adjust that cavity gap inside of your part, you can click on your part, then you go here under tools, and the first icon here that you see, it is to control the fitment of the cavity. So usually we offer more values to make it looser because tighter fits are more an issue than looser fits usually. So you have here several values that you can apply to make that fit a little bit looser in this case. So the minus values, as you can see here on the image, I don't know if you can see clearly the arrows, but the arrows are pointing me that the values that contain like negative values here will make my part looser. So I will make the cavity a little bit bigger so the fitting is better. The positive values here will make it tighter, so it will be a little bit tighter. So I can just apply here. So for example, I want to apply like 25 extra microns to make it looser. I select the value here. I will confirm. The software will paint the cavity, just informing you that a cavity fit is being applied in that case. When you mill that case, it is going to apply that extra 25 microns on my cavity here. And in regards to this, so if you're milling, let's say, a type of tie base, and it's always tight for you, and you don't want to add this every time that you import a tie base, right? So under the configurations here, under tools and then configuration, you have an option that is cavity fit, and you can adjust that as default. Okay, so here, and you can tell the software in PMA every time that I am milling like an hybrid case, I want to apply that extra 25 micron. So every time that you import the part next time, it will auto apply during the import. And you need to worry about applying that value every time that you import an hybrid. So you can set that as default on the software as well. This will help you avoiding remember exactly the value or which is the fit that you need. Just make sure that the tool has an impact here as well, right? So if your tool is a little bit old, it will cause more deflection and to be a little bit harder to mill some materials like PNA or a composite material that is harder. In zirconia is not a big problem because usually we mill that a little bit 20% bigger. Then you have the shrinkage on the sintering later. And zirconia is way easier to mill than PMA or PMA composite, for example, right? But there are ways for you to adjust that issue on the CAM side also. Mm-hmm. Anything you want to add regarding this matter?
No.
All right. So next point, it is regarding the insertion direction for mainly for veneers that we get sometimes that customers, they don't select the proper insertion direction on the veneers. Sometimes they select like the insertion direction directly on from the vestibular area, let's say, and it's not fully correct because the correct insertion direction will be like looking from the top view. It's easier to show that on the CAD, but this will cause you an issue on the CAM when you are importing the file, mainly when you have metadata, because the software will just read the information regarding the metadata from the CAD, and the insertion direction will be incorrect. So when you import your part, the part will look like this. I will just show it on MillBox first, then you can share.
Okay.
Next, okay. So when you import your part, you have something like this, because that's the insertion direction that was selected or chosen on during the CAD design, and that's not the actual insertion direction. Usually the insertion direction will be something like this. So when you import on your part, you have the insertion direction arrow showing you the incorrect one because it was designed like this during the CAD. And that mainly occurs on veneers, not so much in crowns, but in veneers, we got a lot of cases like this. So if you want to adjust here, there are ways to adjust that on the software. So on curves and surfaces here, you have here specify secondary axis, which you can tell the software, oh, that's not the correct one. The correct one is from here. But when you're selecting the secondary axis here, it will try to limit you because that's not the limit. That's not the maximum angle that that machine can access. So sometimes you have first to angle your case, something like this, and tell the software this is the actual secondary axis, the insertion direction for this part, and adjust it from here. But ideally, you would need to adjust that on the CAD side in a proper way. So yeah, want to show Exocad now?
Oh, he's muted. There you go.
Of course, it's muted. Okay, so the reason why that happens is because we've been taught that what's important is to be able to see the margin. You want to see it clearly. So you will, or most people will tend to tilt this to set the insertion direction much more than they should. And so you want to create an insertion direction that is anatomically correct. So it's gonna so it's not really how you're gonna put the veneer onto the teeth. It is the way that it should be inserted if everything was ideal. And so you would want to look at it from the occlusal point of view and then establish the insertion direction so that it is more correct for the nesting also. But that's it would be the difference between doing that or setting it from here where I can still see my lingual margin, and then I tell the software, okay, so this is my insertion direction right here. As long as I don't have an undercut touching my margin, this should be fine. But then this is going to import it in the inverse into the nesting software. So it's not going to go exactly the way that it should. And so if you can, which you should be able to, try to set the insertion direction from the occlusal point of view where you can still see the entire margin. All of this right here, it's all going to be blocked out, so it's not going to be a problem. And then you should be good to go.
Yeah, that mainly happens on veneers, but yeah, it's not a big problem, but you can easily fix that. But it's something that people do all the time.
Mm-hmm.
Yep.
Okay. Okay, so next points regarding, well, again, limitations regarding the machine and the tool set that you have, right? So whenever we are meaning implant cases, like directly to MUA or any type of implants that we have like a screw seat on the parts, right? You need to understand the limitations that you have regarding your tools in this case. Because, for example, if you're meeting an MUA case, you need to have like a screw seat because the screw needs to be screwed, needs to sit on the part that you're meeting, right? But let's say that you have like a screw channel that is 25 millimeter long, but the tool length that you have available for you is only 18. That 18 millimeter length tool won't be able to mill all of the screw channel all the way into the screw seat, right? So you have a physical limitation there. So a way of trying to avoid a situation like this, it is to use an hybrid, like a library with a tie base, because in this way you don't have the screw seat on the part that you are meeting. The screw seat will be on the tie base, not on the part that you are meeting. So on MillBox, this is being done automatically on MillBox. If you have, for example, an hybrid case where you don't have a screw seat and it is like a straight channel and your part has like 25 millimeter length, if the 18 millimeter tool is not able to mill the screw channel from the top, it will automatically finish the rest of that screw seat from the bottom. So it will flip the part and mill it from the bottom. If you have a screw seat on your part, you have a physical limitation there because that screw seat, usually it's a smaller diameter, will block the tool path to be milled from the bottom. There is a way of milling that from the bottom, but it requires a specific tool, which is the next point that we are going to discuss. But whenever you are planning your full arch case, like usually that happens in full arches that are like taller, you need to anticipate that, because if you're doing like an MUA case directly to an MUA and you see that you have a really long screw channel, you can measure that on the CAD and you can see like, oh, my the tool that will be milling that channel there, it's like 60 millimeter. If your channel is 20, it won't be able to mill that. So you can use when you are designing, you can use like a tie base for that case, because the software, if the software is not able to mill from the top, it will automatically mill from the bottom, right? But if it is a case where we have a screw seat, you have to have a specific tool for that. So if you want to show how you can measure that on CAD, and then we'll open here a case in MillBox to show about this.
Yeah, so just to show this here real quick. So what, and please excuse the case. What Yago's talking about is, number one, the geometry that is being used here. Okay, so if you have if you have one that would have a screw seat, then that's going to be that can be a problem. Now, one area where a lot of people make a mistake is they say, okay, but obviously my structure isn't that tall, right? So I should be able to get away with just about anything here, because my structure is actually quite small. If I measure like from here to here, I don't have a problem, right? Now, the one thing to consider is when you have to angle screw channels, you have to consider the length of your tool, as Yago was talking about, and where the shaft ends. Because although you can, you might be able to mill this, no problem, you also have to consider whenever you go to screw this into the mouth and where the shaft ends of your mill machine, which would be the same problem, how deep can it go before it starts hitting your incisal ledge right here? Okay, so if your screw channel is not angled enough and you don't move it away from the rest of the structure, then you have to consider this part of it as part of the length of the milling strategy. And sometimes that sneaks up on you where you say, okay, if I measure my screw channel from here to the interface, I have 10 millimeters. Any mill should be able to do that. Yeah, but you didn't consider this part right here. And so now when your mill tries to get in there, it won't be able to, because the end of the shaft of your tool starts to hit this here, and now you have a collision, or you could have a collision. And so the mill is going to say, I can't do this, right? And so also when you go to screw this into the mouth, where the head of your screwdriver is may not allow you to actually screw this in. And so you may have to overcorrect your screw channel based on the angulation more than you thought would be necessary. Okay, so you want to consider all of that during the design process, so it doesn't sneak up on you when it comes to the nesting and then the manufacturing, like way too late into the process. So those are some of the things that I always tell people look out for, so that you don't run into problems further down the road.
Mm-hmm.
So let me show you here now. So I have 3 cases regarding this. Okay, so this one here, it is a rosin screw. I don't know if it is really long, but this is just to show you. So like Daniel was mentioning, it looks like the same case, by the way. So like Daniel was mentioning, the channel here is not only the part that you should consider. You should also consider the teeth, the design here, because the shank of the tool might collide in that area there. But during the design, you can measure that, like Daniel showed you. And if you notice that, if by the way it is close, or you can clearly see that it will be bigger than the tool that you have available to drill those channels, you can, instead of using a library that goes like directly to the MUA here, to use a tie base. Because in this case, as you can see here, this diameter here, it is smaller than this diameter. So when we are drilling from the top, right, and we're not able to finish clearly all of this channel here from the top, if we mill from the bottom, I have a limitation here, because since this diameter is smaller, I'm not able to finish those walls here, right, with regular tools. So in this case, when we are doing, like when we are meeting a hybrid or a tie base, we don't have the screw seat there. So in this case here, for example, my screw channel has only one diameter. So if, by the way, my tool is not able to finish this screw from the top, so let's say it limits to this area here because it's colliding with the shank of the tool on the anatomy there, like on the design, the software will automatically flip the part from this view and finish it from the bottom. Okay, this is done automatically in MillBox. Don't need to activate anything else. If the software realizes that the tool is not able to finish from the top, it will flip it and finish from the bottom. Okay, so you have a clear screw channel here. So another case that even with hybrids, this might affect you. Maybe it will be a little bit hard to see here, but this is an angled channel. Okay, so this is an angled channel. So even though with an hybrid and you have like an angled channel like this, if the tool is not able to finish from the bottom, depending on the case, depending on how angled it is, we won't be able to finish from the bottom as well, because the angle that you have for this screw channel is being blocked by the cavity part here, let's say. So of course, we are not trying to get rid of this part, like damage this part. So we have a physical limitation, because to be able to mill this channel here, sometimes I will have to clean this area. We might use like 5-axis toolpath to clean that area there, but sometimes like cleaning those areas here, sometimes is a little bit harder. So just take that in consideration if you're doing an angle case as well, okay? So in the case that you see on the design, yeah, I'm not able to use like an MUA with a screw seat there, change to an hybrid, and usually you'll be able to mill that without any issues. Okay, so the next point regarding the angled case that we just discussed, okay? Whenever you are designing a case like this, like we have on the image here, which is a flat screw seat, and it is an angled case, you need to know the limitations of your machine and the tool sets, the tools that you have available for you. To be able to mill an angled screw channel with a flat screw seat like this one here, you will need to have what we call a T tool. Okay, that is a tool that has the shape of a T, which will allow us to get from the bottom of the interface here and mill the screw seat from the bottom. Okay, so this is a physical limitation with regular tools. So whenever we have a case like this, which is angled, I cannot finish the flat screw seats from the top. Okay, with that specifically screw, that specific screw. There are other shapes with libraries and shapes of screws that will allow you to angle, and it will still be able to finish from the top, okay, which is this case that I have here. Okay, this one is a power ball. Okay, so the screw seat, it has like a radius, and it's a like 0.5 millimeter radius here. So I can clearly see the whole screw seat from the occlusal, from the top, without the need of a T tool to mill that channel. So I can clearly see all of the screw seat, so I can apply a 5-axis toolpath and be able to finish this screw seat from the top. Okay, for power balls, for example, I don't need to have a specific T tool to clean the screw seat. But if you're meaning like a desk or any flat screws, be opening here in case to show you. Then you need to make sure that you have those T tools available. Otherwise, it's physically impossible for us to clean the screw seat from the top. Okay, as you can see here. So I don't know how many degrees we have on this, but I would assume like 15 or 20 or something. So here we have a flat screw seat. There is no way for us to access from the top and be able to clean that area. Even though we tilt or apply a 5-axis toolpath here, the tool won't be able to clean and finish this screw seat here. So there are libraries that you have available, like with different screws that you can use, or you can use a T2 here, which I will show you in a moment.
Well, one way to think about it, Yago, and maybe I don't mean to insult anybody's intelligence here, but if you think about your tool, your milling machine just moving straight up and down, there's no tilting of just the tip of the tool. That's an impossibility. Yeah. Mm-hmm. And so how much you can angle your entire tool inside of a screw channel is going to be such a minuscule thing that if you were to measure on that tie base that or on the geometry that Yago's showing right there, if you were to focus on the left side, if you want to zoom in, look at the angle from the screw channel comes from the top, and then how it shifts to the blue shape. That angle right there, there's no way you could reach that from the top. And so that's what he's talking about, that it would have to be done from the bottom. And so that's another thing to consider whenever you're angling things, because you can angle anything. Now, good luck manufacturing it.
That's you can design anything.
Right. That's where things start to get complicated. And so not only do you need to consider that, but you also need to consider how much can your machine actually angle to try to mill a screw channel. Yeah. So there's all kinds of limitations that need to be considered the moment you decide to angle anything. And that's one of the appeals of these new direct to multi-unit screws, that the shape of the head of the screw is, let's say, in a way friendlier, because you don't tend to have these 90-degree angles in some places. So you have the Powerball, which is very round, and you have the seg screw, and then you have the Badger screw. There's all kinds of different screws that are trying to address not only the strength or the pressure through the zirconia, but also the milling capabilities, so that just about anything would work. So that's one of the appeal of these new screws.
And if, by the way, you want to proceed with milling a case like this, you need to have a T2, like we were showing you. So a T2 will do this toolpath here. So it will get inside from this part and will finish this area here. Okay, so it has a T shape like that. So I have a video to show you guys here. Okay, so it will get inside of that area, and it will clean the screw seat. Okay, so if you're doing angled cases with screw seats, and it is a regular screw seat, like even though it's a little bit tapered, you still need the T2. So yeah, just take that in consideration. So if you don't have a T2 available for your machine or set up on your CAM, you need to either find one or use a different library to be able to mill those angled cases.
Yeah.
All right, so next topic is a little bit a hot topic recently. It is regarding iBar. Okay, so it's becoming way popular, iBars, and it is a great workflow. I don't have anything to discuss about the workflow itself, but there is one thing that I would like to mention. Then I'm thinking just on the manufacturing part, right? Because when you are designing outside of the main CAD that you are using, like if you export your parts and you use any other CAD software, not only Blender, but Mesh Mixer or any other CAD software, you kind of lose control about the important parts of your design. Okay, because if you are still on the tree shape or the Exocad workflow, even though you go to expert mode on Exocad, Exocad will block the interfaces and the important parts that it is required for you to build that part properly. It will block you from remeshing or modifying those meshes. Okay, so you're not able to modify those in Exocad. So even though you want to redesign, modify the screw chain or whatever you want to do, you're not able to damage the interfaces. When you export that mesh and you import in any other software, the other software doesn't know exactly which part of the mesh is the interface, which part is the screw channel. So depending on the process that you are doing on the other CAD software, it might be that you might accidentally damage like the interfaces or the mesh of your part. Like sometimes it is an important part of the mesh, right? Which we are going to show you a few bad meshes cases that we've received here. So just take that in consideration. I know that sorry.
No, sorry.
Yeah.
Finish up. Yeah.
I know that on Blender, you have a way to protect the interfaces in the important areas, and it is required for the iBar workflow, because otherwise you'll be damaging those interfaces. And when you're trying to mill that, when you're trying to import that on your CAM software, it will cause you issues. So there are ways to protect the important parts. But as someone that works with CAM cases all the time, I I don't like when on the CAD workflow you export your parts and import on a different CAD. That's my personal opinion. But if you're doing that because of a need, make sure that you're following the right steps in order how to do it.
The other thing I will add is what Yago is talking about, if I may share here. So you are able to design this type of case in Exocad. It takes a little bit of creativity, there's workarounds to do it. But when you create the bar, you want the software to always protect your interface. When you export this STL to a different software, there is a possibility that the new software actually remeshes your mesh. And what I mean by that, if I may, this is why these are called meshes. Okay, it's just a bunch of points connected by lines creating triangles. And so these triangles here are extremely important. And so if the new software you imported to, for whatever reason, needs to remesh and changes the sizes of these triangles, then the topography of your mesh was changed immediately. And now it is not the same. Now, is it a change big enough for you to see a problem with fit? Maybe, but you don't know that until it's too late where you've already manufactured. And so trying to keep things inside of Exocad as much as possible will help you make sure that the areas that need to be protected are protected. This is just an extra bit, but there is a workflow coming out where you'll be able to do this type of things in Exocad with the next version of the software that hopefully we'll get here sometime soon. But you'll be able to keep everything in-house, let's say, to make sure that the areas that the software knows that are important are protected, and you are not able to change it no matter what you do. And that's one of the beauties of keeping everything in-house.
Yeah, if you can keep that mesh, so I would like to discuss a little bit about the mesh itself. Can you flip it
Sure.
again? Yeah, so you can clearly see here that the mesh on the internal side of the MUA here, it is like symmetrical, right? You have like a pattern regarding the triangles here. While on the bar, you can see that there is no pattern regarding the triangles of the mesh, right? So usually the meshes for any implants or screw seats, because it comes from a library, right?
Yes.
So the meshes are very symmetrical. They have like a pattern. So this is very important for any CAM software, because sometimes when we are meeting those areas, we are analyzing how the mesh is, right? And for MillBox specifically, because the metadata from the CAD is not mandatory for MillBox, but as long as you have a good mesh, we are not analyzing that specific mesh to identify where it is an implant, where is the flat screw seat of your case, which is the flat area of this anyway, for example. So this is very important for MillBox. So when you are doing whatever workflow that you need to do on the other software and you don't protect this mesh here, if you are remeshing that, it will damage that information, and you have sometimes a big problem like using trying to build that case there. So in Blender, I know that there is a way for you to create like protection meshes to avoid Blender remeshing those areas. Just make sure that you're following the correct rules when you're doing something like that.
So I just did this here real quick just to show you how different things that are done to the mesh can change the triangles for it. And so you can see that this will have different surface because the triangles are much bigger than the rest of the bar. And so depending on what software you're using, it may want to do something like this to your STL so that that software can understand the shape that you're bringing in a little bit better. So it may remesh your structure, creating bigger triangles and taking away from let's say the symmetry that is created here, and ruins that symmetry. And now it could be a problem. So that's why again I'll repeat myself, but trying to keep things in house is better.
The last topic that we want to discuss is regarding the bad meshes. So let me share again my screen. Okay, so I have here a couple of images regarding bad meshes that we just explained, right? So when you import like an MUA case of the software, MillBox tries to identify that MUA, and it will try to find the information that we just discussed about the mesh, about the screw seat, like it will try to find a pattern on your mesh. If the software is not able to find that pattern, it will not identify that as an interface. And then you either will have to do it manually, or you can use replace or any other features of the software. But the problem here, in this case here on the image that we have on the bottom, as you can see, the part is not even flat, right? The part of the MUA that is supposed to be flat is not even flat. So even though I use replace is a feature that we can replace the interface from the STL and apply an interface from MillBox to guarantee that the parts are being built fine. So for example, on the top image, if I'm sure that curve, the purple curve, it is exactly on the same place, I can extract that weird mesh, the wrong mesh, and apply a replace that is a good mesh that we have in our library, and it will mill fine. But the problem is, like on the bottom part, if the purple curve is not exactly on the position that it's supposed to be, like it's a little bit tilted or it's not on the right position, right? So when I apply the replace, I am applying a replace of a good interface, a good mesh, but in a wrong position. Because during the import here, in this case, the software is not able to identify exactly which is supposed to be like the MUA, what it's supposed to be exactly. So when you're replacing, even though you're fixing the mesh of the case, that mesh that is good, let's say, from the library is not going to be on the same position. Okay, so that is something that might happen with you. So I have here one case to show you. Okay, and as you can see here, the software identified 5 interfaces, but not one. Okay, I don't know if you can see here, but like the mesh,
it looks washed out.
Yes. Okay, and this case, it has a lot of things that are wrong. So if I take a look here from the top, I don't know if you can see here, but there is a weird mesh like flying there in the middle of the channel, and I have another one here as well. I don't know what happened to this case, okay, but those are things that you need to double check on your CAD when you're exporting the file, okay, because it's very, very hard to see like Exocad doing something like this, but there are cases depending, mainly if you're using like the merged walks-up, and if you don't properly treat the mesh that you're using for walks-up, it might happen something like this. You have like a floating mesh in the middle of your case. If it is like on the middle of the case, like here, it's not a problem. But if it is in the middle of the screw channel, this will create you a problem. Okay, we can fix that on MillBox. It's not a big problem. But if I just calculate as it is, okay, I'll have issues and probably a tool break here. Because when you're calculating something on any CAM software, it is trying to give you, let's say, the result exactly the mesh of the file that you're trying to mill. So when you're calculating that to MillBox, MillBox will think that this part here, it is part of the STL that you want to mill. So it will try to prevent like any toolpath to get inside. So maybe the toolpath will be able to get inside that area here. Maybe it's too narrow and it will cause you issues. But for sure, you'll receive a lot of warnings here, inform that it was not able to drill that channel properly. And in this case here, maybe I can fix that in the CAM. But the best scenario here to avoid any issues is to try to fix this case on the CAD side.
And let me show you where things could go wrong here in the CAD side. So when you are designing, especially these full arches, and again, please excuse the ugly design, sometimes you get this type of window, okay? And your gingiva is here, and then your crown is here, and then you get this window. And sometimes we think, if I just move this out, that's all done. But in reality, as you can see in there, you've created kind of like a wormhole that is connecting. So there's still a hole in that mesh that's going from one side to the other. Now, the times I've seen the problem that you showed in the screw channel, Yago, the times I've seen that the most is when this type of thing is happening right on top of the screw channel. And so if you have the screw channel poking through or trying to go through that wormhole, then you can run into problems. Now, the good thing is that these are very easily, you can identify these easily when you're going through the design process. And when you're here, you can see them clearly. If you just make your mesh transparent, you can see where it's happening. A quick way to fix it, if you just exit out whatever step you're on and you go into expert mode, you can select edit mesh. And then by making the mesh transparent, what I try to do is align the two ends of the hole, and then you just select it. Now, make sure you don't close the selection, just leave it like that and click delete so you get a cleaner cut. And then you just go back in and you close it. And now there's no wormhole there. And now if you go back to your freeforming and you start smoothing things out, then you can get rid of that completely. So you no longer have that problem. So that's clean now, even though I still have the same problem on the other side. But if you take the time to just go over your design once you feel you're done, to check for those things, and you can avoid the problem that Yago showed in the case. So just try to get rid of those wormholes or whatever you want to call them. I call them knots. Typically, it's a knot in the mesh. But if you can get rid of those before you finish the calculation, then there's less likelihood of things going wrong.
Yeah, in this case here, I checked together with the customer, and it was something like this. But the problem was that they used like the mesh for a merged WhatsApp, but the mesh had the holes on it. So when Exocad tried to match, let's say, exactly that mesh that had the holes, but the holes were not perfect, creating all the holes and everything else, that merged mesh damaged like the merging of the restoration, and it caused something like this. So once we did exactly like you showed here, we deleted the mesh and we removed all the holes from the WhatsApp.
Okay.
Everything went fine.
Perfect. Okay.
All right.
All right.
So I think that was the last topic.
There we go. Well, very good. I'll take it back over. Thanks, guys. Wow. We went slightly over, but I think everybody stayed along for the ride. We still have 37 of us here. I think everybody stayed. So good. That's awesome. Yeah, thanks for showing that, Yago. Before we get into Q&A. Yeah, let's just get into Q&A actually. So I got one question here. And then if anybody else has any questions that they're thinking of now, go ahead and drop those in the Q&A or in the chat. Either or is fine. I'm also going to hit enter on this. This is just our help.simsystem.com. I want to put that there for you if you need any more resources for MillBox. That link is there for you. But the question I have from an anonymous attendee is, please can we explain the strategy of milling screw retain bridges and crowns? And then they say how to minimize the time and order burrs. So that's the question. So how to minimize the time and order of the burrs, maybe probably just on the strategy, like which order to put certain tools going in. Maybe this was early on I saw this question. Maybe this has to do a little bit with cavity type stuff, but
okay, so I'll quickly show here strategy editor. I'm opening here, just a second. Okay, we have a video about strategy editor as well, by the way. It is on the portal that Alex shared with you. So you can take a look at that because that will be more information than what I'm going to show you here. But on strategy editor, you are able to change the order of operations of your tools, depending on what you want to do. And you can adjust a bunch of things here. In regards the using of the tools itself, I don't know if the question is regarding like tool life, but you can adjust the share my screen. You can adjust the meeting parameters if you have knowledge about doing that. But please, this part here, only play with that if you have knowledge. Okay? Because if you don't have knowledge on this, it will cause you more issues than solving problems for you. Okay. But this is the part where you can assign the tools, change the meeting parameters. For example, here, changing all the meeting parameters that we have inside the software. The CAM is going to tell the machine to follow, right? So we have the RPM, feed rate, like speed, like lateral pass, Z step removal here, like step down. So on the screw 10 cases here, you have a bunch of options for the holes, for example. So any hole bigger than 2.7, it's going to use the 2 millimeter. Then from 2.2 to 2.7, it's going to use a 2 millimeter. Then the 1 millimeter for anything smaller than that. And then for like any other operations here, for example, let's say you have here tool compensation. Okay, depending on the case, that's what we were discussing before about compensating the 1 millimeter when the 1 millimeter is not able to access some areas of the case. So if you have this enabled on your case, it will clean those areas there. So in this case here, usually on the strategy editor, okay, we are doing something different in the near future. It will be the builder where you can control exactly the order of the operations. I will show in a moment. But on the strategy editor right now, you have like first, second, and third for the majority of the operations. So this is the compensation. This is the anatomic details, anatomic part. So we have like first, second, and third. Undercut, we have like first, second. So depending on the operation that you want to change, the order, let's say, you need to play around with that first, second, and third option because each of those options will be in a different position on the strategy. So depending if you select the first or the second, it might create you another tool change or it might avoid you another tool change as well, right? So, but this, you have to know exactly what you're doing here, like I just told you. In the future, we are going to use the builder, which is, you're just seeing the builder here because it's a new release. I don't want to talk too much about it. But with the builder, you'll be able to move around each of those options. You see here, those are the other instances. This is still being developed. Okay, so I'll move all the parts here. Okay, so for example here, let's say that you want to move those parts here later, right? You want to move to at the end of your strategy. So you can easily move. If, by the way, you find something like this, it's because we are creating rules at this moment to avoid you doing mistakes. Because, for example, you cannot start finishing your part and roughing later, right? So we are creating all the rules in order to be able to release this to dealers and customers at this stage. But I think another like maybe 2 months, 3 months, we have this for everybody. So once you have the builder, you'll be able to manage like the order of the operations as well and avoid tool changes. This will be more for dealers, not for end users. Okay. But yeah, it will be a great feature for us to be able to control the order of the operations and avoid tool changes as well.
Great. Thank you, guys. Second question. Can I know how to fix the interface mesh issue in the CAM? Sometimes it's hard to go back to the design process and start from the beginning, especially after separating the bar in Blender. You said that replacing the connection sometimes is not accurate. So how do we
Yeah.
fix the interface mesh issue in CAM?
Yeah, we also have a video on the portal regarding this. Okay.
Mm-hmm.
But for that, we have a replace that we call replace. Okay. So when we are doing here a replace, okay, so in this case here, I don't know which interface this is. I think it's a vortex, but I have no idea which is the length of the vortex. The first thing here is that in this case here, this is a bad mesh, a really, really bad mesh. If I want to replace this mesh here to something that I know it will work good, first, I need to double check exactly where the seat of that interface will be. But here, the software was not even able to identify a seat, like a curve, purple curve here. So probably the mesh is so bad that it was not able to find exactly like a plane for the interface to sit. So in this case here, when you don't have that that proper seat, the purple curve here, I will recommend you to try to do something like this. Go on Tools, Curves and Surfaces, and then you have here cylinder detection. Okay, I would use 3 points, and I would use an area of the software that you have a proper, or at least the mesh is a little bit better. So you create like 3 curves here. Okay, let's see what the software would do in this case. Okay, so it created like a cylinder there, and it created my purple curve, informing where I have my the seat of my interface here. So once you do that, the next step is to tell the software which is the interface, because at this point, the software doesn't know where the interface is, right? Everything is gray. So it is treating that area as an external mesh. So my next step would be to go on Tools and Connections. And then I have here Identify. Okay, then I select OK. And here with cylinders, let me move, I have a zoom bar here. Okay, with cylinders, you can create like information to tell the software which is the interface. Okay, I don't know if you are able to see here, but whatever is inside the cylinder will be treated as an interface. Okay, so I can keep extending that. Okay, so something like this. But here I can clearly see that I have a problem, because you see here that my mesh, it is a little bit beyond the curve that the software will created for me. So I can do like a shift here. Okay, so now I can see clearly that part there. But in this case, since we are going to use the replace, so this will be really hard for you. That's why you need to have a proper mesh from the CAD. Okay, you need to find exactly the value that we have here on the mesh, and sometimes it's not clear. Okay, so let's say it's 0.15. Okay, you only have this because the software is not able to properly find a plane in that area because of the mesh of the case. Okay, so this one seems okay. You will confirm. So what the software is doing right now, it is converting all the mesh that was inside those cylinders, 1 or 2 cylinders, doesn't matter how many you use, and it is exporting that to an interface mesh. Okay, so it will paint in a different color for you. Okay. Right now, on the most recent versions, you have this purple color, let's say. After you have this one, so you have the mesh, it is identified, then you can apply replace. So for replace, let me go back to show you. Go on Tools, Connection, Replace. Okay, select the interface that you want to replace. On the first stage, you either have to select the current interface, so, or if you don't know, you can say unspecified, and then select the interface that you want. I have no idea which interface is this, and I don't know, I think it's a Vortex, but I don't have the Vortex library in this installation right now. But then all you have to do is to select whatever interface it is and confirm here. The software is going to extract this interface and apply whatever mesh I have here from the library. Okay, yeah. So this will guarantee that the interface, the mesh that we're seeing here, it is good to mill, but it will not guarantee that the position is exactly correct, right? Because here, as we saw before, the mesh was a little bit weird. So there is no way for us to tell that is exactly where that implant is supposed to be. right? But that's how you can kind of fix this mesh here. It is a lot of work on the cam, mainly if you need to do that like one by one. It's way easier to go back on the CAD sometimes and make sure that you have a proper mesh before exporting, before saving that case on the CAD.
If the user that posted the questions using Exocad, there's I will say an easier way to fix it, where after you've done your dividing in Blender, you can import those meshes back into Exocad and use them as wax ups. So you're able to pick the right library. So you pretty much starting your case from scratch, except you are just redoing the geometry to adapt your structures to the implant sites. And so because you're importing it back as a wax up, then there's no designing on your part. It's just identifying the libraries, and then next all the way to the end, and then you should have a remesh with a protected part. But this is again all assuming that Blender or whatever other software you're using didn't change the position of the mesh. You can import it back into the software in the right position, and so it shouldn't be that big of a deal. If the person wants to reach out to me, I would love to show them, but I just don't have a case right now to show that specifically.
Yeah, speaking of that, Daniel, would you put your contact info into the chat?
Sure.
We'll be closing up here in a second. I don't think I have any other questions. Yago, I see you making an attempt here on the mesh. We'll wait, see what happens here. We never know. But yeah, Daniel, yeah, Daniel is taking Exocad outsourcing cases, correct? Tell us a little bit about what you're doing, Daniel.
So yeah, I'm an outsource resource, I guess. So if there are cases that are too complex or you have too much work, you can outsource that to me. I'm doing the design myself, so I don't outsource any of the cases that are sent to me. And also train people on how to use the software. That is actually my specialty. I'm a level 3 certified Exocad trainer, or ICTP as they call them. And I can show you any part of the software inside and out for whatever level of understanding you have with the software. So that's kind of what my business is all about.
Yeah.
I'm pretty sure if you're outsourcing with Daniel, you won't have any issues as the one that we are discussing today here.
There you go.
Yeah. And Yago, what's your take on the case there?
Yeah, so I believe it was a Vortex, but yeah, this one seems to be fine. So we can mill this interface here like it is right now. But again, I'm not sure if the position here is exactly the same, right? The height and everything else, but it looks good. It is properly nested there, but we never know. So it's way easier to go back on the CAD, like Daniel mentioned, and fix that on the CAD, just to make sure that the everything else is fine, right? Because yeah, we have ways of fixing that on the cam. But what happens if by mistake because of the mesh there, the interface, it is like 0.1 millimeter off, right? Then you mute this case, you discover that after sintering, you lose like a bunch of time, a zirconia disk or whatever. So it's way better to go back on the CAD side, even though it takes a little bit of more time, and make sure that the whole workflow is correct since the beginning.
Yeah.
Perfect.
Yeah. Well, thank you guys so much. Yeah, that really does seem to be one of the morals of the story here, is make sure you understand each part of the process, including green state. You brought that up, Daniel, quite a bit. And so thank you guys so much. Really thankful for your attendance and just the opportunity to share about this. If you have any questions, feel free to reach out to me, Daniel, or Yago. Daniel put his contact info in there if you're interested in having him help you out with some Exocad cases. He's a great designer. Otherwise, just very thankful you guys were here today. And with that, we will conclude. Thank you guys so much.
Thank you.
Thank you.
Thank you. All right.
Bye.
Ciao, guys.